Hello friends, today I'll solve a LeetCode daily challenge called minimum difference between largest and smallest value in 3 moves. So we are given an integer array nums. In one move, we can choose one element of nums and change it to any value. We need to return the minimum difference between the largest and smallest value of nums after performing at most 3 moves. So in any move, we can change any element of nums to any value and we can perform at most 3 moves. So we need to find the minimum difference between the largest and smallest element of nums. So let's consider the first example. Here we are given a nums array of size 4. We can make at most 3 moves. So first in the first move we are changing this 2 to the value 3. Similarly in the second move we are changing this 4 to value 3 and in the third move we are changing this 5 to value 3. So at the end the array becomes all 3's. So the minimum difference between the largest and smallest element is 3 minus 3, that is 0. So as the size is 4, we can choose any 3 element and we can make their values equal to the fourth element. Similarly in the second example we are given a nums array of size 5. In 3 moves we are changing the element 5, 10 and 14 to 0, 0 and 1. So at the end the array becomes 1, 0, 0, 0, 1. So the difference between minimum and maximum is 1 minus 0, 1. And if we consider other possible combinations, we can say there is no other way to make the difference less than 1. So let's discuss the idea how to approach this problem. So let's say the max 4 element in nums array is b0, b1, b2 and b3. Similarly, let's say the minimum 4 elements are a0, a1, a2 and a3. And all the elements are in increasing order. So that is b0 is less than equal to b1, less than equal to b2, less than equal to b3. Similarly, a0 is less than equal to a1, less than equal to a2, less than equal to a3. So before performing any moves, the maximum difference will be, that is the max element of nums minus the mean element of nums. That is, here the max element of nums is b3 and the mean element of nums is a0. So we are given the smallest 4 element, then the largest 4 element, and in between some numbers will be there. So instead of 3 moves, let's say we are given we can perform at most 1 move. Then we can say either we will move the element a0 to a1. Let's say if a0 is moved to a1, in that case the difference will be b3 minus a1, or we can move b3 to b2, that is reduce the largest element to the second largest element. Then in this case the difference will be b2 minus a0. So here we are allowed, like it's not necessary that we need to move b3 to b2. We can move b3 to any value. So if we increment b3, then it's going to increase the difference. So we need to make b3 less than or equal to the second highest element, and it should be greater than a0. That is, we cannot make b3 less than a0. Then in this case, like the difference will be anyway greater. Similarly, while moving a0, we need to make it greater than or equal to a1 and less than or equal to b3. That is, it should be any number which should lie in the range a1 to b3. So the answer will be minimum of b3 minus a1 or b2 minus a0. So in one move, we can either move the minimum or the leftmost element, or the maximum or the rightmost element. Similarly, let's say we are given only 2 moves are allowed. So you will see there are three possible combinations. So let's consider the first case where the smallest two elements are moved, that is A0 and A1 moved to the range A2 to B3. That is any value in the range A2 to B3. So in this case, the difference will be B3 minus A2. In the second case, let's consider the smallest value is moved anywhere between A1 to B2 and the largest value B3 is moved to anywhere in the range A1 to B2. So in this case, the difference will be B2 minus A1. And in the third case, let's say we move the largest two element, that is B2 and B3, and move to any value in the range A0 to B1. So in this case, the difference will be B1 minus A0. And we need to consider the minimum of these three. So with two moves allowed, so we can move either the smallest two elements or the smallest element and the largest element or the largest two element. And we need to take the minimum of all three differences. Similarly, if we are allowed only three moves, either we can move the smallest three element, that is A0, A1 and A2 moved to any value in the range A3 to B3. In this case, the difference will be B3 minus A3. Similarly, I'll move the smallest two element and the largest element, that is A0 and A1, move to any element in the range A2 to B2, and B3 is moved to any element in the range A2 to B2. In this case, difference will be B2 minus A2. Similarly, in the third case, I'll move the smallest element, that is A0 to any element in the range A1 to B1, and the largest two element B2 and B3 to any element in the range A1 to B1. In this case, difference will be B1 minus A1. In the last case, I'll move all the largest element, that is B1, B2, B3 to any element in the range A0 to B0. In this case, the difference will be B0 minus A0, and we need to consider the minimum of these four values. And as we can perform at most three moves, so if the size, so if length of nums array is less than equal to 4, then we can return 0, that is move n minus 1 elements to the nth element. So for example, we are given the array 5, 3, 2, 4. So as we know, we can perform at most three moves. So I will move all these three elements to 5. Then the array becomes 5, 5, 5 and 5. So here the difference will be 5 minus 5, that is 0. So or I can move all the elements, that is to 3. So in this case, the array will be 3, 3, 3, 3. The difference will be 3 minus 3, that is 0. So if the size of the array is 4 or less than equal to 4, then I can say the output will be 0 always. So what we need to do, first I'll sort the nums array. So the smallest 4 element will be at the beginning of the array and the largest 4 element will be at the end of the array. Then I need to compute these 4 differences and I will take the minimum of these 4 values. So let's understand this with example. That is, we are given a nums array. So first I'll sort the nums array. So after sorting, the value becomes 0, 1, 5, 10 and 14. So here the smallest 4 elements will be, that is, a0 will be 0, a1 will be 1, a2 will be 5 and a3 will be 10. Similarly, the largest 4 elements will be b0 will be 1, b1 will be 5, b2 will be 10 and b3 will be 14. So we need to consider the minimum of b0 minus a0, b1 minus a1, b2 minus a2 and b3 minus a3. So in the first case, all these 3 elements 5, 10 and 14 are moved to 1. So the array becomes, so the difference will be 1 minus 0, that is 1. In the second case, the smallest element is, let's say, moved to 1 and the largest 2 element, that is 10 and 14, let's say move to 5. So here the array becomes 1, 1, 5, 5, 5. So the difference between largest and smallest element will be 5 minus 1, that is 4. Similarly, in this case, let's say the smallest 2 elements 0 and 1 is moved to 5 and the largest element, that is 14, is moved to 10, the second largest element. In this case, the array becomes 5, 5, 5, 10, 10. So the difference becomes 10 minus 5, that is 5. That is the difference between largest and smallest element. In this case, the smallest 3 elements, that is 0, 1 and 5, let's say is moved to 10. So the array becomes 10, 10, 10, 10, 14. So the difference becomes 14 minus the smallest element 10, that is 4. So the minimum difference will be minimum of 1, 4, 5 and 4, that is 1. So first we are sorting the array. The time complexity will be big of n log n. And in the second step, we are doing the constant number of operation, that is we are computing the minimum of 4 elements. And we can find all these differences in big O of one time. So we can say the time complexity will be big O of n log n. So as we have discussed, we are only concerned about the minimum 4 element and the maximum 4 elements. So instead of sorting, we can use two auxiliary arrays. So I will maintain a auxiliary array, let's say min 4 and a max 4 of size 4, and initially all the entries will be initialized to infinite and it will be minus infinite. So first I will fill the main array. So the first element is 1. I can see the 1 is less than the current element, that is infinite, so I'll insert 1. Similarly for the next element 5, I'll start from the first index. 5 is greater than 1 I'll come to this index. Here 5 is less than the current element, so I'll insert 5. Similarly, I'll go to next element, that is 0. So I can see I'll start from the 0th index. 0 is less than the current element, so I'll insert 0 and I'll shift each element by 1. So 1 will be shifted by 1 position and 5 will be shifted. Now for 14, I'll linearly traverse. I can see 14 is less than this element, so I'll insert 14. Now I'll come to 10. So I'll linearly traverse this min array, and here 10 is less than 14, so I'll insert 10 here and I'll shift 14 by 1. As there are no space, so 14 will be removed out of the min4 array. So the resultant min4 array will be 0, 1, 5 and 14. So filling the max for it will be exactly opposite. The first element is greater than the current element, so I'll fill it here at the last index. Similarly for 5, I'll start from the right. I can see 5 is greater than 1, so I'll shift the current element by 1 position and I'll insert 5. Similarly, I'll go to next element 0. I'll traverse from the right. So 0 is greater than this element, so I'll insert 0. Then I'll go to next element, that is 14. So I'll start from the right. Then I can see 14 is greater than the current element 5. So I'll insert 14 and I'll shift each element by 1 position. 5 will be shifted here, then 1 comes here, then 0 comes here. Now I'll insert 10. I'll start from right. I can see, so 10 is greater than 5, so I'll insert 10 here and I'll shift each element by 1 position. 5 comes here and 1 comes here. Now the elements in max 4 will be 1, 5, 10 and 14. Now we need to take the difference of these values and we need to take the minimum. So for each element we are linearly traversing the min4 array to insert that element. So for each element we are doing at most 4 operations. So computing this min4 array will take big O of n time, and computing the max4 array will take the big O of n time. So the time complexity will be big O of n, and we are using two arrays of size 4 which is constant, so the space will be big O of 1. So now I will code the solution. So I am declaring a variable n which stores the length of the nums array. If length of nums array is less than or equal to 4, we know that result will be 0. Now I will sort the nums array. I'll declare a result variable which is initialized to nums of n minus 1 minus nums of 0. So now I have declared a result variable which is initialized to nums of n minus 1 minus nums of 0. So now I need to consider, or I need to take the minimum of nums of n minus 1 minus nums of 3. Similarly, nums of n minus 2 minus nums of 2, nums of n minus 1 minus nums of 1, and nums of n minus 3 minus nums of n minus 1, then nums of n minus 4 minus nums of 0. So I'll run a for loop for int I equal to 0, I less than equal to 3, I plus plus. So I'll update the result to minimum of current result and nums of n minus 1 minus 3 minus I minus nums of I. So for I equal to 0, it will be nums of n minus 4 minus nums of 0. Similarly for I equal to 1, this term will be same as nums of n minus 3 minus nums of 1. Similarly for I equal to 2, this term will be same as nums of n minus 2 minus nums of 2. And for I equal to 3, this term will be nums of n minus 1 minus nums of 3. So at the end, I'll return the result. So let's run it for the sample test cases. Sample test cases are running fine. Now I'll submit it. So you can see it's working as expected. As you are sorting the array, and after that we are doing some constant number of operation. So the overall time complexity will be big O of n log n. In the second approach, I have discussed a order of n approach. So I have attached the GitHub link for the order of n approach in the comment. Please do check it out. If you have any doubts or suggestion, please post it in the comment section. I will be happy to help. If you like this video, please subscribe. Thank you.